So our next, this is actually a theorem this time. Our next theorem that we're going to talk about is angle side, or excuse me, angle side, the angle side theorem. And we're going to prove this, right? Remember, a postulate is something that we accept as true without proof. A theorem is something that is a conjecture that we prove to be true. And so angle side, just like you would think, is if we have two angles and a non-included side of one triangle congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. Okay, so basically, if we have two angles, right, and a non-included side, right, so not the side between the two angles, but a side that is apart from the two angles, and it has to correspond. So notice how A and D correspond, right? And the side that is adjacent to those angles, or that's part of forming those angles that's not included, is the side that's congruent, right? So if we had this side congruent here, that wouldn't correspond, right? Because that's part of E, not part of D, right? And E would correspond with B, not A. So they have to be the corresponding side that's congruent, okay? And if that's the case, then we can say that triangle ABC is congruent to triangle DEF, right? We can say these two triangles are congruent, which means all their other corresponding parts are congruent. All right, let's see if we can prove it. So angle side or angle side theorem. So if I want to prove that if I have two angles, right, angle A and angle F congruent, or two pairs of angles, I should say. So angle A and angle F, and angle B and angle E, if those are congruent, and a corresponding non-included side is congruent, DF and AC in this case. So notice how A and F are both part of those, right? So A and F are part of them, but B and E are not part of them, right? So that's a way to tell just by the letters that they correspond. Okay, they're next to A and F, those corresponding angles, but they're not next to B or E, right? They're not included between the two angles. All right. So that's what we're given. We're given that two pairs of angles and one non-included corresponding side are congruent, and we're trying to prove that the two triangles themselves are congruent. Okay, so we'll start the givens. So angle A is congruent to angle F. Angle B is congruent to angle E. And side AC is congruent to side FD. All right, and those are all given. So what can we say next? Well, if we know two angles are congruent in two different triangles, we can say, because of the third angle theorem, we can say that the third angle is congruent, right? So we can say, well, angle D must be congruent to angle C, right? Or I could have written that the other way around. Angle C is congruent to angle D. But either way, it's because of the third angle theorem, right? Which says if I have two angles congruent, two triangles, then the third angles must be congruent. All right, so now that I have that, now that I know this is congruent to this, now look what we have. Angle, side, angle, angle, side, angle. Okay, so we have two angles and an included side congruent in these triangles. And so that must mean that the two triangles are congruent, right? So triangle ABC is congruent, and let's just make sure the order is right. So A goes with F, B goes with E, corresponds with E. Oops, put the wrong one there. And then, of course, D would correspond with C. All right, so we know that's true because of angle side angle, and we've proven what we set out to prove, right? So there's a proof of the angle side theorem. And we, of course, use the angle side angle postulate in order to prove that.